In this video I'm looking at the solution to question 6 of the June 2010 Edexcel M1 paper. The topic of the question is kinematics. Well, the question tells us that a ball is projected vertically upwards with a speed of 14.7 meters per second from a point which is initially 49 meters above the ground. We're to find the greatest height above the ground reached by the ball, the speed with which the ball first strikes the ground, and the total time from when the ball is projected to when it strikes the ground. In the first part of the question then, we're to find the greatest height that the ball reaches above the ground. So remember, we're launching it vertically at a speed of 14.7 meters per second from a point which is initially 49 meters above the ground. So to find the maximum height, we use the idea that the velocity at the top of the motion will be 0. So using v squared equals u squared plus 2as, we know that the final velocity is 0, and taking the upward direction as being positive, 14.7 squared, and then minus 2 multiplied by 9.8, because the acceleration is negative 9.8, multiplied by s. This solves to give s is equal to 11.025 meters, but we want the actual maximum height above the ground, so max height is equal to 49 plus 11.025, which to three significant figures then is 60.0 meters. The marking in that part of the question was as follows. It was a method mark for using the equation of motion, a mark for substituting correctly into that, and an A mark for getting the value 11.025, and a final A mark, which is actually a follow-through mark for adding on the 49 to your answer to S. So 4 marks in that part of the question. In part B of the question, we can again use v squared equals u squared plus 2as, but this time we want to find v when we know that it has fallen through a height of 49 meters from its starting point. So the initial speed upwards was 14.7 meters per second. The acceleration is downwards 9.8 meters per second. So this time, using up as being positive, we've got v squared is equal to 14.7 squared. That's 14.7 squared. And then plus 2 multiplied by negative 9.8 multiplied by negative 49. That gives a value of v, when we've taken the square root, to be 34.3 meters per second. In part C, we can do a similar thing using equations of motion. This time, if we know v, so if we use v equals u plus at, we can say that speed that we found in the first part of, part B of the question, minus 34.3. This is taking the initial direction upwards, is equal to the initial upward speed, which is 14.7, and minus 9.8 times t. That gives a value t is equal to 49 divided by 9.8, which gives us a value of 5 seconds. This could also have been done by using s equals ut plus a half at squared. So this would have been given then as negative 49 is equal to 14.7 t minus 4.9 t squared. And solving that would have given you two values. You get a quadratic which factorizes to t plus 2 and t minus 5 equal to 0. So taking the positive value of t, t is equal to 5 seconds. So whichever way you prefer to do that will lead to the answer of t equal to 5. The marking here was given as a method mark and an A mark for correctly using the equation of motion, and then finally an A mark for the answer of 34.3. In the second part, again, a method mark and A mark for using the equation of motion correctly, whichever method you did, and an A mark for using getting a value rather of t equal to 5 seconds. Okay, well, that completes the solution to that question. Solutions to further questions can be found at www.furthermaths.org.